Hey friends, over 10 billion, that's 10,000 million. That's how many transactions Azure Storage processes every minute. It's been 6 years since we did an episode about Azure Blob Storage. Klaas Langhout is here to give me a refresher on how it works and to update me on what's new today on Azure Friday. Hey friends, I'm Scott Hanselman and it's Azure Friday. Today we're talking about Azure Blob Storage with Klaas. How are you?
I'm great. How are you, Scott?
I am living the dream. I am learning all kinds of great stuff on Azure Friday, and what's great about it is I get to take these techniques and I literally, when I'm done recording the show, I apply them to how I use the tools. So I'm excited how you're going to help me save money, optimize costs, and probably use blobs in ways that I haven't thought about.
You betcha. You betcha. So I always like to start off just with a little context on blob storage because, frankly, a lot of people don't know what it is. So blob storage is an unstructured data store used in Azure, and it's used by both first-party services as well as third-party services, ISVs, enterprises, and the like. And we look at four discrete workload areas, and we look at application development. So basically, customers building high-scale applications in Azure where the unstructured data store, which is separate from disks, is really useful, especially when you're dealing with exabyte scale and high throughput. And some of the specific use cases are listed in the left column. The mobile applications, the web applications, CDN, and then we also support interactive or low latency workloads, which is somewhat unusual for cloud storage in that we have an SSD-based tier called Premium Block Blob Storage. And that's unique in the cloud, in the public cloud space. We also have analytics, whether it be Spark or Hadoop. And we also support HPC with that high throughput that I mentioned. We can go up to the 50 gigabits per second on egress, which is very high. And then we can also go higher depending on the workload requirements. And then lastly, cold storage. So cold storage is what most people think of when they think of a object store, where it's backups, archival of PST files, images, legal retention holds. And that's pretty common, but it's not the thing we really focus on as much just because it continues to grow. But frankly, the requirements are cheap and durable. And we've had that for a long time. Any questions so far, Scott?
So I'm seeing, though, a really broad spectrum between, like you said, interactive, low latency, the SSD-based premium stuff where it's blob storage, but it really has low latency, all the way down to cold storage where it's like, I'm going to store something and I just need it there for years and years and years. But it's all the same product.
That's right. And one of the key things that we focused on with analytics as an example is that we built the hierarchical namespace as well as the per file ACLs and folder ACLs directly into our object store, which is also somewhat unique in the public cloud space. So we call it reducing silos. So in some frameworks, you would have to copy data from one thing to another thing in order to get access through specific protocols, such as NFS, which we have in preview today, or the HDFS API. And so our model is to erode those silos where you can ingest over one protocol, and then you can make use of these other protocols such as NFS or HDFS for that data without having to move it to yet another bucket or another container.
Mm-hmm. And is it true that not only am I a customer of Azure Blob Storage, but Azure itself is a customer to you? So this is truly the base of the pyramid, and everyone is sitting on top of this compute and Azure App Service and Kubernetes, like they all need these things to work.
It is, Scott. And it's actually been really fun for me because I get to talk to external customers, external partners that build their solutions on top, as well as internal partners. No surprise, Teams is one of our biggest users, and their demand spiked heavily over the last year. OneDrive, SharePoint also are extremely big users of Object Store. And as you pointed out, it really is a foundational element of the Azure pyramid.
That Teams example is a really interesting one because, in the news, everyone's like, Teams numbers are up and they say this many users and that many users, but they never talk about the base of the pyramid that all those things stand on. So while cloud usage and people working in OneDrive and in SharePoint and sharing files in Teams and all of the different things, all that pressure is on blob storage to really make it happen.
It is, and honestly, when the lockdown first occurred, the demands, the throughput demands that they had required us to do some extra work just to meet that demand until we could actually get in front of their capacity requests. So it was a fun time, frankly, and it was a nice thing to do to basically stretch ourselves to meet their needs, because by doing that, we also meet our external customer needs.
And one last question before I let you continue that I find fascinating is that the sizes of the files. I mean, there's access models, there's mediums that it's stored on, there's access, frequently accessed and high and low latency. There's cold storage, but like I store tiny JPEGs and then I use Azure CDN to front that. But someone else might be storing, unrendered frames for a movie that they're going to make, and they're going to be storing 40 gig files. That's another thing that's amazing to me, that I can throw my little 4K JPEG up and it just takes it, and someone else can throw up a 40 gig movie file, and that's cool too.
Right, and we actually recently launched 200 terabyte file size support. So even for customers such as media and entertainment, where they are rendering movies, or oil and gas, where they also have seismic files that are much larger than 5 terabytes in size, we're the only public cloud to support an individual blob or file that's up to 200 terabytes in size.
That makes me feel some kind of way about my JPEGs, but I'll let you continue.
Well, and for the JPEGs, we like to think about the premium tier, the SSD tier, as being pretty unique and interesting, because when a customer comes to us and says, hey, where I'm constrained is in the transactions per second. So I'm dealing with, say, 10 KB file sizes. And I really do want to get, 50,000 transactions per second or higher. That's something that we recommend the premium tier for, because since it's SSD, its performance for especially small file sizes is much better than spinning disk. That, coupled with the fact that SSD provides much lower latency on the order of 4 to 8 milliseconds, provides a much better experience. And what surprises customers, and I was going to mention this later, but I'll mention it now, is that if the transactions per second is high enough, the premium tier, even though the GB cost is really expensive, the total cost can actually be lower because the transaction price is much lower. And so we do have a recommendation in our portal where we look for accounts that have a high transactions per second amount. And then we suggest to them, hey, have you thought about premium? Because you'll get a lower bill in that case, and you'll also get lower latency and higher transactions per second.
See, this is really interesting because you've already, even before you got to any kind of demo, you've already taught me something, because I have a blog that has bursts of traffic, and it's unique in that it has no database. Each blog post is stored in a file, and I've been blogging for 20 years, and I've moved my blog into Azure, and it stores everything in about 7,000 XML files of very small size. And when it boots up and when it accesses this thing, it basically for loops over 6,000 files.
Right.
And it's been running on a virtual machine for many years, and I thought to myself, I'll put it in Azure App Service. I'll use path mapping over to Azure Storage. And I found the performance to be not what I wanted, because I was for looping naively over kind of probably the wrong blob storage workload. And I'm hearing from you that premium probably would make that happen for me.
Yeah, we have a large retailer that moved part of their workload to premium explicitly for thumbnails that appear in an end or a consumer-facing website. And so they've split their usage between the different tiers based upon what the workload needs. And so they use the premium tier for the thumbnails because they do want that as an interactive workload to load very, very quickly, where some of the other information on their website they can pull from the standard tier, because they don't need that same latency requirement.
Fantastic. This is super useful information. Please continue.
You bet. So that's kind of the overview of what blob storage is. I wanted to touch on, what are the cost drivers, and then I'll go into a demo. We think about capacity costs. So basically, how do you monitor and control the amount of gigabytes that you're using? Transactions already touched on, where premium can be cheaper if you have a high transaction load. the redundancy choice, and I have a specific slide on that just because it's easier to talk about graphically. And then lastly, the network costs. And the one thing I'll mention there is that we do now have something called routing preference, where the default is that all access happens to the local point of presence of Azure, and then it tunnels over the Azure backbone. So if you try to write a file or a blob or read a file or a blob, and your on-premise instance is, say, in Europe, you will actually hit a European data center. It'll tunnel over the Azure network and then hit, say, a storage account that's in, say, the Western states. With routing preference, you can turn that behavior off, which instead causes that client or on-premise instance in Europe to go over the internet to access that data center, our Azure data center that's on the West Coast. And that will lower your network cost. So it gives you more flexibility to choose, do you need the resilience and the losslessness of the Azure network, or can you survive a little bit of noise and instead go over the internet and save some cost? So with that, let me touch upon the different tiers. And this is a huge part of our cost savings approach, where you have these 4 different tiers, and we have automation that the customer can choose to determine what tier it's on between hot, cool, and archive, and move data before that, which is one of the demonstrations I'll have. And this shows that the GB cost goes up as the heat increases, and the transaction cost goes down as the heat increases. And so you can automatically see that for colder workloads, they should be stored on archive because it will actually save money. For the redundancy choices, when you create a storage account, you have to choose how much redundancy you want. And the cost starts out low on the left side and increases on the right side. On the left side, the locally redundant storage, or LRS, that is durable to drive or hardware cluster failure. And so we do write at least 3 copies, or the equivalent of 3 copies, before we acknowledge the write, and we make sure that it's durable to drive or cluster failure. The next one over, zone redundant storage, is redundant to losing an entire zone. And it also has the added benefit that it provides higher availability, because if we lose one zone, there's no impact to the application or the user that is using that storage. All the same I/O that's already occurring will continue to occur even with that zone being down. And then we have the geo-redundant storage, or synchronous options, GRS, which takes a copy of the data and asynchronously copies it to a secondary region, typically over 300 miles away. That happens after the write is acknowledged. So the RPO in most cases is around 15 minutes or so, and you can see what it is, but that gives you a secondary copy to make sure that the data is durable, even if we had a catastrophic problem in a region, such as an earthquake. And so that's what we recommend for the portions of the data where it does need to be regionally durable.
Mm-hmm. And that term, the RPO, the recovery point objective, can you explain that really briefly?
You bet. So the recovery point objective is basically a measure of any sort of resiliency option, which describes how far away the data is from the current time. And so an RPO of 0, and it's a little premature, but we are working on something there. But an RPO of 0 would mean that at the point where a recovery is attempted, that there would be no data loss, that every single write that was made up until T0 could be recovered from. Mm-hmm. An RPO of 15 minutes means that data from 15 minutes in the past could be recovered too. And so if you're designing an application, you would fit your data into different categories. Like I've seen patterns where some folks will use, say, Cosmos DB for structured data, and also for the replication options that they choose for that portion of their data. And then for other portions of their data set, they would actually use blob storage with that different RPO promise, because they can survive not having the data up to, say, like the last 15 minutes in that second day.
Okay, so the part that I heard there that was most important to me was the categorization of data. So for example, if I'm relying on blob storage theoretically to keep track of orders, I don't want to lose anything. But if I'm keeping track of user comments, if 5 minutes of user comments are lost or something like that, or ratings are lost, it's not the end of the world.
That's exactly right, Scott. And the common pattern I see is that a lot of customers or partners will move to Azure, and they'll initially do like a lift and shift of their application. And then what they'll start to do is they'll start to SaaS or pacify it, if you will, to convert it to a more modern structure with maybe serverless constructs, and start to separate their data from what was predominantly, say, disk in IaaS world, into using our Azure storage options to separate that out from compute, and then to pick the right tiers and the right options for the different portions.
At the beginning of our conversation, you had said impossibly large numbers, like 40 terabytes and multiple terabytes. And then on this slide here, you're saying 6 replicas in 2 regions. Seriously? Like they put one file up and you can keep 6 copies of 40 terabytes in multiple places. That's amazing.
That's right, Scott. And one of the promises and basically the principles that Azure started with was to really focus a lot more on durability, where our lowest cost option is still durable with 3 copies, the equivalent of 3 copies. And I've talked to customers before who have said, for their disk workloads, for instance, because this is a common platform that also includes disks, how do I configure RAID? And I want to make sure that I'm tolerant to losing a drive. And we have to explain to them, you can do that, but it's not really necessary because we already are keeping redundancy beneath them at the platform layer.
That's cool. All right, what's next?
With that, let me switch to a demo. So here I have my Azure portal open, and the first thing I'll show is I can do a search for reservation. And if I click on purchase, this gives me the list of the different Azure services that include reservations, and we're talking about blob storage. So if I go here, it'll show me the different options that I have. Close that. And all I just want to draw attention to is that you can pre-purchase a quantity in either 100 terabyte chunks or 1 petabyte chunks for the different access tiers and the different redundancies and the different regions, where you pre-purchase it either 1 to 3 years. And this gives you up to a 38% discount in your bill right off the bat. So that's one thing to do if you know you're going to be using a set of storage for a prolonged period of time, say 1 to 3 years. The second thing I wanted to show is how easy it is to set up a lifecycle policy to reduce your cost by lowering the tier that it's in. And so for this one, I'm going to go ahead and use So this is my storage account, which is the thing that maintains block blobs, files, tables, and queues. And then down here on blob storage, I see lifecycle management. So I'll go ahead and select lifecycle management. And then I'm going to turn on access time tracking. And so access time tracking will allow us to also base a rule not just on last modified, but also the last time object was read. And then I'll go ahead and add a rule. And then, so for instance, for this rule, which I'll call lower cost, I'm going to apply it to all the blobs in my account, but I could just apply it to a specific subset. And I'm going to say it's true for all block blobs and then snapshots and versions as well. And then I'm going to say last access. And I'm going to say, if it wasn't read in the last 60 days, go ahead and move it to a cool tier. And then I'm going to specify if it gets accessed again, move it back to the hot tier, because I know in my workload, if I read a blob or a file, I'm probably going to read it again a few times. And then I'm going to add another block to basically say, if I haven't accessed it for 180 days, then I just want to move it to archive storage. And then from a policy requirement in my workload, I'm going to say that if I've had the data for, say, 10 years, I just want to delete it from a policy. So I'm going to say 10 years, which is 3,650 days, and I'm going to say delete the blob. And really, it's that easy.
So would it be an audit moment where I would know that, or I don't worry about that kind of stuff?
So you can track through the diagnostic log. We manage all of the information there. And you can also take a look and get a listing. We have another feature called inventory, where you could get a listing of all of your objects with the last modified or the last access date timestamp. And then you can run tools such as Synapse against that inventory file to get telemetry information about what's happening in your object store. So that's something we're working on the side to increase the ability for the end user to understand their data estate.
Nice.
So with that, I also just wanted to leave with the fact that you can actually go to aka.msblob. And when you go to aka.msblob, you'll see our entry point in Azure.com as far as talking about blob storage and some of these features.
Fantastic. I feel like I'm enabled now to go back and kind of reassert and reevaluate how I've been using blob storage. It seems like I've been using it somewhat naively, and there's even more tools available to me that I did not realize existed.
Thanks, Scott. Yeah, we've been busy in the last year, and we're continuing to add a lot more functionality as far as how to gain greater insight and automate some of the actions that you want to do with your files or blobs.
Fantastic. I am learning all about Azure Blob Storage, how to track my own data estate and optimize costs today on Azure Friday. Hey, thanks for watching this episode of Azure Friday. Now I need you to like it, comment on it, tell your friends, retweet it. Watch more Azure Friday.